So chapter 6 is actually in your ebook. So we're back to our regular ebook. Does have some of what we already did. If you look at, like, if you're the type of person that uses your book as a reference, that's fantastic. But if that's you, you'll see that the beginning of this section is what we already covered, which is everything in not everything, but things in degrees. How do I graph an angle in degrees? How do I determine a coterminal angle for that angle in degrees? All that stuff happens first. And then it switches into something called radians. So for a lot of people, just the concept of radians is hard, okay? But the radian is just a different way to measure a circle. There are two ways, if you go back to your geometry stuff, like we're doing circles right now in geometry. So if you can go back 365 days in your brain, okay, we were talking about circles. And there's two ways to measure a circle. One is in degrees, and for that you're talking about in terms of 360 degrees. It would go 0, it would go all the way around to 360 degrees, and that's the measure of the circle. And it's the same as the central angle. So if you remember that, like this angle here is 90 degrees, so this, okay, so that's the measure of your circle. So the central angle is the angle on the inside. The arc's measure is the same. So if I said to find an arc that has 90 degrees, I would go to the angle that has 90 degrees and it would be that, or vice versa. If I had the angle, let's say my angle is, 30 degrees here, this arc's measure would also be 30 degrees, okay? That's measure. When you're talking about length, now it's the actual physical length of the arc, as though you could take a string, wrap it around the edge, and then lay it against a ruler. So measure is degrees and length is in centimeters or inches or something like that, okay? Because it's length. So again, if you're talking about like taking a string and wrapping it around a pizza and then laying it against a ruler, that would be length of the arc. And the formula for length of the arc in geometry is the measure of the arc over 360 times pi r, times 2 pi r. And this is because you're finding what portion of the circle's length would be multiplied times its circumference. So you would take the whole circumference, and if it was 90 degrees, it would be 1/4 of that circumference, something like that. So this is how we did it in geometry. What we are going to do is find it this way. I call this SOAR because it's S equals theta times R, and the theta looks like an O. So S stands for arc length. Don't ask me why. It makes no sense. There is no S in the word arc or in the word length, but that's what they use. S equals theta, which is the measure of the central angle, times the radius. Now the catch is here that this theta has to be in radians. So we're going to first talk about how do I get to radians, and then I have to pay attention that that is always in radians. So if it gave it to me in degrees, if I said 30 degrees was the arc measure, I have to convert it into radians, which we're going to learn how to do in a minute. And then all I have to do is multiply it times its radius. If it's in a picture, it will give you the radius. Let's say that's like 3. That's the radius. That's your R. If it's just written out, it might say theta equals 30 degrees and R equals 3. And then you're literally converting to radians, which again, we're going to teach in a minute, and then multiplying it times the radius. The biggest thing is you can't leave it in degrees, and that's the mistake people make, okay? You with me so far? So that's the first formula we need to know. The second is what the heck's a radian, okay? So a radian is a unit of measure that is part of your circumference. So if I have a circle and I measure all the way around it, what's that called? Circumference. How do I find circumference? 2 pi r. Now we're going to talk about a unit circle, and a unit circle has an r of 1. So what would be the entire arc length or entire circle length? Good. It would be 2 pi. All the way around the circle would be 2 pi. That is radians. A whole circle is 2 pi radians. If I go halfway, so I start at 0 and I would go to 2 pi. If I went halfway over here, that would be pi. If I did half of that at the top, pi over 2. If I did 3/4 the way around my circle at the bottom, it'd be 3 pi over 2. Those are your quadrant angles, and they're going to become very important, okay? When we talk, part of the homework tonight will be to draw out an angle or locate what quadrant it's in radians, and that's important. So on the right, it would be 0. At the top, it's 1/2 pi, or pi over 2. On the left, it's pi, or 1 pi. On the bottom, it's 3 over 2 pi, or 1 1/2 pi. And then all the way around your circle is going to be 2 pi. So if I ask you to locate pi over 6, where would that be? Which quadrant? It would be in my first. So think about it. If you want to ignore the pi for now, this would be 1/6. Which two quadrant angles would be would 1/6 be between? 0 and 1/2, right? So this is going to be in my first quadrant.
What's the first one? Says 0 over 2 pi.
0 is the first point, and then all the way back around ending would be 2 pi. So like 360 would be 2 pi.
Oh, okay.
What if I asked you to tell me where 3/4 pi is, or 3 pi over 4? That would be second quadrant because it would be in between 1/2 and 1. So, I mean, it would be actually dead smack in the middle, but it would be there, okay? This would be, pi over 6 would actually be small because it would be over here, but you get the idea, okay? What about if I said 5 pi over 4? Ignore the pi part. 5/4 is what mixed number? 1 and 1/4 is 1 and 1/4 between 0 and 1/2, 1/2 and 1, 1 and 1 1/2, or 1 1/2 and 2. It's in between 1 1/2 and 2. I mean, what? 1 and 1 1/2. And then if I said 7 pi over 4, convert 7 over 4 into a mixed number, what's that? 1 3/4. Where would that be? The fourth quadrant. God bless you.
So if you find which quadrant and you make it into like a whole number and a fraction.
If it's an improper one. Like if it's smaller than 1, you don't need to. But if it's improper, then yes, I convert it to that.
And if it's just a fraction that like you don't need to convert.
Then you're saying, is it bigger than 1/2 or less than 1/2 really? Because it would be in first or second quadrant. So 2/3, second quadrant, because it's bigger than 1/2, right? 3/7, first quadrant, because it's less than 1/2.
Okay.
Yep. Yeah.
What would happen if we had like more than 2? What would we do?
Oh, that's such a good segue. We're gonna get to that because you would find a coterminal angle
You have more than 2 more.
if it's bigger than 2. There's actually 2 ways to do it. I'm gonna teach you today the coterminal, and then I'm gonna teach you a shortcut later. But for now, that's where we're at. Okay. Questions so far? So understanding those quadrants is important because there are going to be questions that say, what quadrant does this angle fall in? All right, so to find coterminals, if you think about it in degrees, we add and subtract 360, right? 360 is our full circle in degrees. In radians, it's 2 pi. That's our full circle. So whatever's there, we're going to add and subtract 2 pi. If I want to make it bigger, I add 2 pi. If I want to make it smaller, I subtract 2 pi. All right. Oh, go back. All right, so it says find a coterminal angle. On the homework, it actually says find 2. It says find 1 positive and 1 negative. So let's change it so the directions match that homework question. So if I go to 1 and I've got 17 pi over 6, the first thing is like where 17 over 6, is that bigger than 2 pi or less than 2 pi? It's bigger than 2 pi. So I can actually subtract 2 pi from that and keep it positive. Does that make sense? So I'm going to subtract 2 pi. Now I got to change them so they have the same denominator. So 2 pi over 1 becomes what over 6? 12 pi over 6. And 17 pi over 6 minus 12 pi over 6 is 5 pi over 6. That would be a positive coterminal. So would 17 pi over 6 plus 12 pi over 6. That also is coterminal. You just have to pay attention to, is it giving you the range that it has to be in between 0 and 2 pi. Now, if I wanted to find a negative coterminal, I already subtracted 2 pi, so I would have to take what I just got and subtract 2 pi again, or 12 pi over 6. And I get negative 7 pi over 6. Camilla. That's your 2 pi. So you have to give it the same denominator. I said the homework says 1 positive, 1 negative, so let's practice that. Yeah. Okay, before you move on to 2, think about what this would look like on your unit circle. What do we know about coterminal angles? What do they look like? God bless you. Same start, same stop, right? So the one we have in between 0 and 2 pi, the easiest one I would say to graph, is 5 pi over 6. What quadrant is that in? Nope. Second. It's in between 1/2 and 1, right? So 5 pi over 6 is actually here. Because it's in between 1/2 and 1. It's close to 1. Now, if I wanted to graph negative 7 pi over 6, I have to go the other direction. I start here, but I go negative. This would be 1 and 1/6 pi. So negative 1 is here, 1/6 past it, ends the same spot. And then 17 pi over 6. Convert that into a mixed number. 2 and 5/6 pi. So 2 means all the way around my circle once, and then 5/6 more, and I start at the same spot. So for right now, if that makes sense to you, that's perfect. I am going to teach you in a little bit like a trick to get around your circle a little bit faster. But for right now, if you can understand that, then that's important, right? Because coterminals should always start and stop at the end. At the same spot. Okay, so if I want to find 1 positive and 1 negative coterminal of negative 4 pi over 3, where do I start? If I want to find a negative, I can subtract 2 pi. And over 3, that's 6 pi over 3. And I get negative 10 pi over 3. And then to find a positive one, I'm going to add 2 pi or 6 pi over 3. And I get 2 pi over 3. So here's my negative, and here's my positive. So if it asks you to graph these, because it will, it's going to ask you what quadrant is it in, and there's multiple choice to find the angle. If it asks you to graph something like negative 10 pi over 3, and obviously you don't know how to work that perfectly yet, then you could just find its coterminal. You could add 2 pi until you get to something between 0 and 2 pi, and then those you'll know how to draw. So if it said, what quadrant is negative 10 pi over 3 in? I would add the 2 pi until I got to positive 2 pi over 3, and then I would know that's in what quadrant? Second quadrant, because it's in between 1/2 and 1.
If it asks to graph that, we just graph the positive one?
Yeah, so the graphing part is multiple choice. So you'll see it from your thing. Yeah. You would know it's going the other way because if it's if it's negative 10, it went all the way around it once and then it stopped there. But you would know where it stops and starts. Question so far? Okay, so if I want to convert from degrees to radians and radians to degree, if you have something and you need to graph it and you have absolutely no idea where it lies in terms of pi, then your option is to convert it to degrees. The goal, to be honest, is to not have to do this. The goal is to get so comfortable with your unit circle in terms of radians that you could graph it without converting it. But if you're stuck, if you have no idea how to convert it, how to graph it as it is, then you can take something that's in radians and you can convert it to degrees by multiplying times 180 over pi. And then there's going to be questions that just says take this in degrees and convert it to radians, and that we do theta times pi over 180. This is what you're going to do to get your angle in radians for arc length. So if it gives you the angle in degrees to find the arc length, we're going to first convert it to radians and then plug it into the equation. Clear?
Can you just hold on for 1 second?
Yeah. All right, this whole slide is converting from one to the other. Here's the biggest thing, is that just because it doesn't have a pi doesn't mean it's not in radians. The only sure way to determine which one it is if it has a degree symbol, it's in degrees. If it doesn't have a degree symbol, it's in radians. So as you glance at this slide, 3, 4, 5, and 6 are all in degrees. 7, 8, 9, 10, and 11 are all in radians. It has to have a degree for it to be a degree. It does not have to have a pi to be in radians. Does that make sense? Okay. All right, so we're going to start with the conversion. So if it's in degrees and I want to go to radians, I multiply it times pi over 180. There are going to be times you won't have your calculator and you will need to simplify that. Oh my gosh, you can divide by 5. I promise you, you'll be okay. The look on his face. So if I divide this by 5, let's start there. 27. Divide this by 5, 36. Can I reduce it again? Yep, 3 goes into both of these. Actually, 9 goes into both of these. Okay, I could have done 3 and then another one, but 9 goes into both of these. 3 and 4. So this is 3 pi over 4. Go to 540. 540 times pi over 180. First thing I would do here is cross through my zeros, divide by 10, cross through those zeros, get rid of them. What goes into both 54 and 18? 9 goes into both. Other things go in there too. 2 could go in there. You could start it however you want. But 9 goes in both of these. This would be 6, and this would be 2, and 3. 1 and 3. So I'd get 3 pi. Camilla. It'll say convert. Oh, it could be convert one way or vice versa. It might not necessarily say specifically degrees to radians or radians to degrees. It would say either way.
But it gives you just...
It has to have a degree symbol for it to be a degree. Okay. Yep. Otherwise, it's a radian. All right, weight on 5, weight on 6. Let's go to 7. Now we're in radians. So we're going to multiply times 180 over pi. If pi's already there, the pi's are going to cancel. And then the 6 goes into the 180 30 times. And I get 5 times 30, or 150. Yep.
Why is it like 180? Why is it not 360?
Because 1 radian is half your circle. And at half your circle, it's 180.
Oh.
Does that make sense? Okay. Yeah.
And since we're doing it like radians and degrees, we would get jeopardized for the degree symbol?
No. As long as you're going in the right direction, I don't know that I'd take points. Yeah. All right, go to 8. I'm multiplying times 180 over pi. The pi's are going to cancel. 4 and 180 are both divisible by what? You could start with 2, 2 and 90, and now 2 again, 1 and 45. So then I have 3 times 45. and that's 135 degrees. 150. So do you see now that if I asked you to graph 3 pi over 4 and you had no idea what quadrant it was in, you could convert it to degrees and then locate it. It's just going to take you longer than you need to, and the faster you are at these by the end, the better off it's going to be. Yep.
What if like the bottom, the denominators are canceled?
It could be, you could, so it's 2 ways. 1, you could leave it as a fraction, which would be fine. 2, it might tell you to round to the nearest blank, and then you would actually want it like that. So pay attention to the directions in the homework, because sometimes they say round to the nearest whatever, and then that means I would take something like this and I would keep going. In the calculator, I would do 3 times pi, not 3.14, but actually pi, and divide it by 4. So 3 times pi, and your pi button is over the little caret that's like at the top of your, like there's divided by, it's right above there, divided by 4, and that's 2.356, whatever, so on and so forth. So if the homework, and there are times, it's usually with arc length, that it will say round it to the nearest 10th or 100th, and that's what it means, actually multiply it out. Okay, and then 9, so if it's negative, that negative is going to be there at the end. You keep that negative. It's always there. You don't lose that negative. But I'm going to multiply this times 180 over pi. Good. So the negative is there. I don't want it here. I'm not multiplying times negative, but it's going to be part of my answer. The pi's are going to cancel. 2 goes into 180 90 times, and my answer is negative 90. Questions so far? All right, now you go to 10. Is 10 in radians or degrees? It's in radians, so we're going to multiply this times 180 over pi. There's nothing to simplify across, so we're going to literally multiply 180 times 5. And I get 900 over pi. If it wants it kept exact, that is my answer. Most likely this type will tell you to round. So if I did 900 divided by pi, I'd get 286.48 degrees. Yes. So anytime in the homework it says you can round to blah, 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 feel free to grab your calculator. Yeah. It's above the caret. So the caret's like above your division symbol. And it's above that. Yeah. Sure. All right. So then 11 in radians, right? So times 180 over pi. And I'm going to do 2 times 180. So 360 over pi. And I'd get 114.59 degrees. I'm actually going to check and see if WebAssign forces the degrees. Remind me to do that when we're done, okay? Otherwise, you might get it wrong without it. So, questions on those? All right, last thing, and then I'm going to go back to radians because I'll show you how to do something else. But it is called arc length and area. So we already talked about this. Arc length is theta times r. This is your SOR. Area of a sector, so now we're talking the full area of the piece of the pie. So arc length is the outer ring. This is my length. And if I fill in that piece of the pie or piece of the circle, the area of that space is the area of the sector. And the formula for that is 1/2 r squared times theta. Again, theta must be in radians. So the very first thing you're going to do is look at what's given to you for your angle, identify if it's in radians or degrees. If it's in radians, you just have to plug it in. If it's in degrees, you have to first convert it to radians and then plug it in. All right, so 12 says a circle has a radius of 18.2 centimeters. Find the arc length and area of a sector with theta being 3 pi over 8. So if I want to find length first, it is theta times the radius, and then I'm going to find area, and that's 1/2 theta times the radius squared. For both of these, theta has to be in radians. Is 3 pi over 8 in radians? Yes, so step 1's already done for us. For the length, we're just going to do 3 pi over 8 times 18.2. Rodrigo.
For the area of the sector, is it 1/2 times theta r squared? Or
Yeah.
Is it divided times?
Or you could put it all over 2. There's no difference.
So it's not-
Yeah, you could do theta r squared over 2. That's the same. All right, so without a calculator, I would just multiply out the 18.2 times 3. God bless you. And I'd get 54.6 pi over 8. If it says round to the nearest blank, then I'm multiplying that out. So I'm doing 54.6 times pi divided by 8, and it says it would be 21.44. And this time it gave you a unit of measurement, which is centimeters, which makes sense because that's length, right? And length would be in centimeters or inches or something like that. Claire?
In our answer on the test or something like that, we always have to put units, right? You'll take points off.
I mean, probably not, to be honest. Yeah. Yeah.
And then when you rounded, you multiply like with your calculator.
I went straight across. Yep. 54.6 times pi and then divided that answer by 8. All right. Area of the sector would be 1/2 theta times r squared. So it would be 1/2 my theta, which is 3 pi over 8, times 18.2 squared. 18.2 squared would be 18.2 times 18.2. I'm going to cheat and use a calculator. 3 pi over 8, because usually you would have it at that point. 331.24. And then I'm going to multiply straight across. Like I said, usually if this is not a whole number, you're usually going to get a calculator. If it's a whole number, you could see it without the calculator. So I could do 0.5, like in my calculator, I could literally do this whole thing. 0.5, 3 pi divided by 8 times 33.1.24. I could type that whole thing in. You could use your fraction feature. It doesn't matter. From there, I get 195.12 centimeters. And because it's area, it's what? Centimeters squared. Good.
Oh, right, we already, never mind.
Yeah.
Will we ever not have a calculator?
Yes.
Like, it's a whole like,
It would, I don't know, your radius might be like 6, and then you got to square 6. Like, they're not bad. And then you would leave it exact, because that is not, so if the word says exact, you have to leave it exact. This is rounded, so it would not be exact. I think on the homework it says around, so you'll know. Questions on that one? Oh, sorry. All right, 13 says, the circle has a radius of 18.2 centimeters with theta being 144 degrees. Find the arc length and area of the sector. So what's different this time? It's in degrees. Step 1 is convert it. 144 times pi over 180. What goes into both 144 and 180? I mean, that's fancy pants. I would have gone with 2, but sure. 2, 72, and 2, 90. What goes into both 72 and 90? 9, so 8 and 10. And what goes into both? 2, 4, and 5. So we're just going to keep going until we can't go any further. So this is 4 pi over 5. Theta in radians. Now, arc length and area of a sector. So 4 pi over 5 times 18.2. I'm going to do 18.2 times 4. 72.8 pi over 5 would be exact. 72.8 times pi divided by 5 is 45.74. That would be if you rounded it. Yeah.
And then for this, what would be the units?
This is still length, so we still grab centimeters.
In centimeters squared is one for area.
Say again.
Centimeters squared is one for area.
Correct. All right, so then 1/2 my theta, which is 4 pi over 5, times r squared is 18.2 squared. 1/2 4 pi over 5. We already did 18 squared. 18.2 squared, which was 331.24. So then I can again do this any way I want. I can do this as just as is, as like in fraction. I could do 1/2 the fraction times 4 pi over 5, the fraction times 331.24. I could go straight across all my numerators and then divide by 10. Like you could do this a lot of different ways. You just got to make sure whatever you're doing makes the most sense. I would probably do 0.5 times 4 pi divided by 5 times 331.24. 416.25 centimeters squared. Yeah.
So is this something we have a calculator for or no?
I would say if it kept it exact, it'd be on the left-hand side, something like that. You should be able to do without a calculator. Something on the right-hand side where maybe it's not like the decimal that you're squaring, then that would be without a calculator. But if not, like the homework's going to have, I think the homework says to round. So you would have the calculator for the homework at least. Valeska.
Is your theta always in, do you always want to convert it to
For those formulas, yes.
and for the area, is it always in centimeters?
It depends on the length. So it could say, if that said 18.2 inches, then it would be inches squared. It just depends on the unit that they give you.
And then why does it already, so it already gives it as in degrees, right?
It gave it as degrees, but we converted it, and you only have to convert it once. Once we convert it, we can use it. Yeah. No.
And you know the original area sector, why is the theta 4 pi over 5?
Because you have to take that 144 and convert it into radians. But we did it already. Once you do it once, you don't have to do it again. Sure. Actually, can you stay for 2 minutes? Because what I'm about to explain to you. Okay. What I'm about to explain to you is like something that people have struggled to get, but I want to stress that it's like one question on your homework. So we don't need to give ourselves so much pressure, okay? But what I'm about to explain to you is how you would draw a radian if it didn't have pi in it, okay? If you understand, this is like so minute of the big picture of what you need to know, okay? But you will get questions, maybe 1 or 2, occasionally on this, okay? So I'm going to teach you. So pay attention because this is like abstract, but once you understand, it's so easy, okay? If I went all the way around this circle, what would it be in radians? 2 pi. What if I replace pi with its unit with the 3.14? What would that be? 6.28. Okay, would be 2 times pi. You with me so far? It would be pi we would do 3.14. But then 2 times that would be 6.28. So 2 pi is the exact same, well, not exact same thing. It's the rounded, okay, as 6.28. If I saw an angle that said, where would 2 pi be? It's on the x-axis. Where would 6.28 be? On the x-axis on the right-hand side, okay? Which means, what if I said draw 6 radians? A little less than that. So 6 might be here. What is halfway on the circle in terms of pi? It's just 1 pi. So if I asked you that without the pi, you'd tell me it's 3.14. So if I asked you to draw 3 radians, where would that be? A little bit less. As a matter of fact, it's directly across from 6.
But isn't 2 pi equal to 1 radian?
No.
Come on. I got lost.
2 pi is 2 times pi radians. So 2 pi is 6.28 radians.
What's 1 radian?
1 is 1 radian. So the easiest way to draw the rest of them is to take this space from 0 to 3 and divide it into thirds. So about 1/3 the way is 1 radian. About 2/3 the way, which is a little bit bigger because 1 pi over 2 would be 3.14 over 2, which is 1.75. So 2 is going to be slightly bigger than that. So if I wanted to draw 2, it'd be about there. If I wanted to draw 1, this is not very accurate, but it would be about there. And then if I just extend those lines across the way, that is my 4 and my 5. So if it asks you to find which quadrant 4 radians is in, you can use this little map, okay? Just behind the 2 pi, just lower than 2 pi would be your 6. Shoot across the circle, that's your 3. Take from 0 to 3, divide it by thirds, and that's your 1 and 2. Go across the circle, that's your 4 and 5. I think that's the easiest and fastest way to do it. If that totally freaks you out, convert them to degrees and figure out where they are. So 4 radians times 180 over pi, because that's how I would convert from radians to degrees, would be 4 times 180 divided by pi, which is 229.2 degrees. And 229 is in between 180 and 270, so I know it's in the third quadrant. Yeah.
Would you have a calculator for a question like this?
It's probably not going to be on your test.
Oh.
Yeah, I'm not going to guarantee it, but it is probably not going to be on your test. No. Yeah.
It said like, I don't know, like 9 and keep going from 6, but on the same marks, but continue to like add 1. So
Yeah, or you can do 9 minus 6, because that's like a coterminal-ish. So you'd know you'd go from here 3 more. Does that make sense? They're not usually bigger than 6, I would say. I think in the homework it's not bigger than 6. It'd be between 0 and 6. Okay, questions? Okay, and again, you can always also take those pi's over 2. I could take pi over 2, and I could convert that by literally dividing pi over 2. And what did I say that was? 1.57. And I could take my 3 pi over 2 and do 3 times pi divided by 2, and that's 4.7. So down here is 4.7 radians. You could also do that, but I don't want you to stress too much about it. There is a question on the homework on it because it's important to understand it, but it is not going to be something that is a majority of the information you're going to be quizzed or tested on.